Okay, so we are going to start 11.2a with just some terminology to make sure that you know what it is we're talking about in these. I've been trying to introduce some of this terminology to you already so that as we learn it today, you're like, oh yeah, I know what that is, right? Like prism, for instance. I've talked a lot about prisms in the last couple days. We're going to focus on prisms today. Now, if you go in modules to the top of the chapter 11 module, you will see this. Okay, this is the formula sheet that you're going to use throughout the rest of this chapter. Today, we're going to live right here, which means we are using this formula today, and we're using this formula today. You will use no other formulas on this sheet. Yeah, I was going to put some stuff on here, but most of you probably don't have this pulled up, so we'll just do it in the notes. But what I need you to see is there are 5 different figures we're going to talk through in chapter 11. There's a prism, a cylinder, a pyramid, a cone, and a sphere. Notice the prism and cylinder have the same formulas. The pyramid and cone have the same formulas. Here's why you're going to love this chapter. I'm going to teach you the prisms today, and then tomorrow I'm going to teach you the cylinders, and you're going to be like, this is so easy because we did it yesterday, just adding a new shape in today. So I think the repetitiveness of it, because there are 2 different shapes that go with each formula, is super helpful. But just know this is at the top of your module. You should use it when you're doing your homework. Have this in front of you, because when you're taking your test, you're going to have this in front of you. Okay, so just get in the groove of, here are my formulas, what do I do with them? Okay, with that, I am going to get rid of that and come over here, and we're going to talk terms. So the first key term, like I said, is a prism. When we talk about a prism, it is a polyhedron. Remember, that was a 3-dimensional figure that has polygon faces and bases, okay? With exactly 2 congruent and parallel faces, and we call those the bases, okay? A polyhedron with exactly 2 congruent and parallel faces that we call bases. So if you look at your 2 figures there, this pentagon is congruent and parallel to that pentagon. We call those our bases, okay? Not because they're on the top and bottom, because I could rotate that figure so that it looks, I wonder if I can do that on here very easily. Let me try something. There we go. Same figure, right? Your bases are no longer top and bottom. They're left and right. So don't just assume the word base means bottom. It doesn't. It's the 2 things that are parallel and congruent to each other, okay? So in the next figure, which we're calling a triangular prism, what are your bases? Triangles, because they are parallel and congruent. So this is a base, and this is a base, okay? All of your other faces, the non-bases, are called lateral faces. Lateral meaning, okay, football players. What's a lateral?
Hold on a minute. You go that way.
A lateral. You pass it to the side, right? Or behind. You don't pass it forward, right? The side. Lateral. Do we not know that, really? I didn't play football, guys.
We don't call it like a lateral. Side shuttle pitch.
Side shuttle. A pitch, yeah. Okay, well, you're welcome for a new football term. A lateral is a pass off to the side. Your lateral faces are your sides of the figure that are not your bases, okay? So this would be a lateral face, this would be a lateral face, all the way around, lateral faces, okay? It's the faces that are not bases. I'm not trying to rhyme so much. With that, then, do you notice anything in the lateral faces for these 2 figures? What are they? There are right angles in them. They're all what shape? They're all polygons. What polygon? They're all rectangles, okay? When you have a right prism, like most of ours will be, your lateral faces are rectangles, okay? So go ahead and write that one in. When you hear the word altitude, what do you think? Height, okay? So altitude and height are essentially the same thing. An altitude of a prism is a perpendicular segment that joins the planes of the bases. So if you're putting your two bases, connecting your two bases perpendicularly, that's an altitude. The height is the length of that altitude. So height and altitude are pretty interchangeable, okay? If I look at this picture, I would say this, the red, is my height. It's the distance between the two bases, okay? If I look over here, I would say this is my height, the distance between the two bases. Now, all of that is if it's a right prism. A right prism means perpendicular to your bases is your height, okay? And that's an edge of your figure. An oblique prism still has a perpendicular height, but it's almost like you took a little, just shoved the side and it leaned a little bit to make it oblique. Now your height is not part of the figure anymore. We rarely work in oblique. Most of what we do in this chapter will be right prisms or right pyramids. There will be a few obliques thrown in there, but very few, okay? So in an oblique prism, some or all of the lateral faces are non-rectangular, sorry. Those are more like parallelograms then, right? When we make it oblique, this doesn't look like a rectangle anymore. It looks like a parallelogram, okay? Okay, enough of the terminology. Here's what you're going to do. You are going to find what's called the surface area of a prism today. So it might be a triangular prism, might be a pentagonal prism, might be a rectangular prism. Any type of prism is going to have this formula for surface area. But I am always going to ask you to give me two things, the lateral area and the surface area, because you cannot find surface area without knowing the lateral area. Okay, so I'm going to give you two formulas right now. The first one, I don't like the size of that pen. Hold on. The first one is lateral area. And maybe you want to just put a little key off to the side here. Whenever you see LA, it's lateral area. This is for the whole chapter. SA is surface area. Anyone remember what the LA formula was from that chart that I showed you at the beginning? pH. Good job. LA is pH. So that's one of the formulas you're going to use. And then to get to surface area, SA, it's going to be your lateral area, LA. Okay, now think about this. Your lateral area is the area of everything but your bases, right? It's your lateral faces, the ones that wrap around. So what do you suppose you have to add to that to get the whole surface area? Two what?
B.
Bases, 2B. Okay, now take a little pause, move over to the side, and we're going to define a few variables here. And these are going to help you a ton. Keep this with you. Maybe write these things on the formula sheet that you're going to use every day with your notes. I mean, just write it in your notes right now. But when you do the homework, it's super helpful to have this. P. What does P typically stand for? Perimeter. Okay. It is perimeter in this chapter, but it's more specific. It is the perimeter of the base. Okay, so whenever in this chapter you see P, you need to think the perimeter of the base. So if your base is a triangle, it's the perimeter of a triangle. If your base is a rectangle, it's the perimeter of the rectangle. Okay, so that's P. When you see an H in this chapter, 90% of the time, we are talking about a height, but not just any height. It's the height of the figure. Okay, another way to think of it in a prism, it's the distance between your bases. Oh, rough time to have to bring food. Okay, and then the last one that I want you to write down here is that capital B. A capital B does not stand for a length of a base. I know it's tempting to think that because B, lowercase b, is the length of the base, right? Capital B is the area of the base.
Sorry, I have a question.
Okay? Yes.
What is the purple parentheses? What is that?
The distance between the bases. Yeah, that's just my shorthand. Sorry. Distance between the bases. Okay, now, in the homework, it might say on a couple of them, use a net to find the lateral area and use a net to find the surface area. I'm going to do a net for you right now just so you can understand what it is, but hear me. You don't ever have to do a net for me, ever. Okay, if it says in the homework to use a net, you can do it just using the formula, okay? Luke, this is for you. So I'm gonna draw a net for you right now, and then we'll walk through it. Look at this picture for me, this rectangular prism. What would you see as your bases? Top, bottom, left, right, front, back. What makes sense to you as the bases? Top and bottom, okay. So we'll use these as your bases for my net, okay? Okay, so if that's the case, to draw the net, we're gonna open it up. I'm gonna start with the back face, just so you know where I'm at when I do this. But I mean, you could really start anywhere you want. This back rectangle has dimensions of L by H, right? So I'm gonna go L by H. This is L. This is H. So do you see that? That's the back of my figure. Now, if I'm going to open it up, this side has dimensions of W by H. So this is H. I'm going to go W units over. Okay, next to that would be the front face, which has a length of what? It's an L. They just made it a straight L, yeah. And then next to that would be the left side, which has a length of W. Okay. Can anyone tell me what this big rectangle represents right now in this figure? Not the perimeter.
Outside, without the bases.
Without the bases. It's the lateral area, right? This is the lateral area of this figure. It doesn't have the top and it doesn't have the bottom, okay? Let's put in the top and bottom. So your top and bottom, this right here, has dimensions of W and L. So we're going to go L by W. I'm going to put one there, and then I'm going to put the other one up top here. And you don't have to put them right here. It's just where I'm choosing to put them. You could have put them along a different piece of it. This would be your net, okay? I just want you to understand why this is helpful. If I say find the lateral area, I'm saying find the area of the blue. So if you forget the formula or how to use the formula, you know how to find the area of a rectangle, right? Base times height, base times height, base times height, base times height. If you find each individual rectangle and add them all together, you'll get there. It's not the fast way. In fact, it's a very slow way. But if you just blank and you're like, I don't remember how to use this formula, you could always do that, okay? Okay, here's what I want you to see. The formula is P times H. That's the perimeter of the base. Now think about this. The perimeter of the base is W plus L plus W plus L. Do you see W plus L plus W plus L anywhere else? Look right here. The length of the rectangle. If I look at this as one big rectangle, the length of that rectangle is the perimeter of the base. So when I'm finding this area, I'm taking length plus width times H, right? Times the height. Base times height. Does that make sense? And if it doesn't, it'll make more sense once we actually work one out. But that's what's happening. That's how they came up with this formula, is here's this big rectangle, find the area of it, base times height, okay? The lateral area then takes all of that and adds 2b to it. Why?
Because, I mean, that's just the lateral, you have to include the bases.
The surface area needs the bases. So we add this base and we add this base, and now you have your whole surface area. Okay, so lateral area is just the lateral faces. Surface area adds the bases to it. Okay, let me show you how we do this. And like I said, if the book says make a net and find it, you do not have to make a net. I'm not going to make a net anymore moving forward. Here we go. Okay, so here's my advice to you. When it says find the surface area in the quizzes and the test, I'm going to say find the lateral area and the surface area. I want both those things separately because then I can give you more partial credit if something goes off the rails. So I would do this. LA, this is a prism, so the formula is P times H. What did we say P stands for?
Perimeter
Of the base, okay? The perimeter of the base. Now, what do you want to use as your base right now? Because you could technically use any sides. 4 and 3. So let's call this a base and this a base then. Okay, top and bottom. You don't have to. You could use different ones. We're going to do top and bottom. So this is P, the perimeter of that base. So we want the perimeter of this rectangle. How do you find the perimeter of that rectangle?
4 plus 3 plus 4 plus 2.
4 plus 3 plus 4 plus 3, right? 4 plus 3 plus 4 plus 3. The other way you could do it is 2 times 4 plus 2 times 3, right? Or 4 plus 3 times 2. There's lots of ways to get there. What is that?
14.
Oh, yes. Oh, no, I did 14 in my last class. All of a sudden, I thought I did 12 in my last class. So that's 14, okay? That's your P. What does H stand for?
Height, or the distance between the bases.
Height of the figure, which is the distance between your bases. What number is that?
5.
That's the 5. The distance between the bases, okay, is your H, which is the 5. So H is 5. So if I want the lateral area, I go lateral area equals perimeter, 14, times height, 5, and I get 70 what? Centimeters squared. Okay, so that's your lateral area. We're trying to get to surface area. So now, write that formula down. Surface area is your lateral area plus 2 times B. What is LA? 70. That's what we just found. This number is going to drop in right here. 70 plus 2. And then we have to figure out what B is. How do you find B? What is B? What does B represent? Area of the base. What shape is your base? A rectangle. Do you hear how many questions this is to ask yourself, right? What shape is my base? My base is a rectangle. How do I find the area of a rectangle? What's your formula? Base times height. So your B right now is base times height. What are your base and height in this base? 4 and 3. Okay, now tricky. You told me earlier H was 5. That's the height of the figure. That's this H. This H is part of your area of your base, and that is a different H. Okay? That's the area of just the rectangle. So if I'm trying to find the area of the base, it is 4 times 3, or what? 12. So that means my surface area is 70 plus 24, or 94 square centimeters. How'd that feel?
Not terrible.
Good. I think the trickiest part of these, you guys, it's not a hard problem. What's hard is making sure you know the next move, right? But when you know the next move, when you have your teacher asking you all these leading questions, It's pretty easy to get there. The trouble is I'm not asking you leading questions when you're taking a quiz or a test, right? So you really have to get used to the routine of it and like what comes next. How do I find H? How do I find B? How do I find P? What are those? So just as you're doing the homework, ask yourself those questions as much as possible, okay? Okay, look at number 2. It says find the surface area. That means we have to start with the lateral area. Okay, and it's a prism. Lateral area of a prism is what formula? pH. What does P stand for? Perimeter of the base. What shape is your base? A triangle. Okay, so these are your bases right now. How do you find the perimeter of that triangle? It's missing information.
It's for the Pythagorean theorem.
Pythagorean theorem, right? That's a right triangle. I know 3, 4, what's that triple? 5. If you don't know the triple, then you just plug it into Pythagorean theorem. 3 squared, plus 4 squared equals that hypotenuse squared, and solve for C, okay? At this point, you should know the Pythagorean triple 3, 4, 5. Most of them that show up, 6, 8, 10, 5, 12, 13, they're pretty common. But if you don't know them, plug it into the Pythagorean theorem, okay? Okay, so I know 3, 4, 5 up here. What is P?
So 12.
P is perimeter of the base. Your base is a triangle, so the perimeter of that triangle is 3 plus 4 plus 5. So your perimeter is 12. That's that number. What's H?
6.
H is the height of the figure, right? Which is the distance between your bases. So the distance between your bases here is this length. So your H is 6. So if I'm doing P times H, I'm going the lateral area is 12 times 6. So 72 square centimeters. Gosh, my pen is a terrible size right now. I'm sorry. We'll try this. Okay, then we need surface area. And your surface area is the lateral area plus 2 times the area of a base for a prism. What's LA?
72.
You found the lateral area. That was the 72 plus 2. And now you have to figure out what B is. Now, stop for a minute here. What shape is your base? A triangle. B stands for what? What about the base? The area of the base. Okay, so here's where you got to figure out. My capital B right now, it's the area of a triangle. What formula is the area of a triangle? 1/2 times base times height. Now you used a height already as 6. Is that your height here? No. So you're going 1/2. What are your base and your height in that triangle?
3 and 4.
Good job. 3 and 4, right? Here's the right angle. Base and height are 3 and 4. So your capital B is 1/2 times 3 times 4 or 6. Okay? That's what goes here. So now you say my surface area is 72 plus 2 times 6, so plus 12. So my surface area is 84, what? Centimeters squared. Any questions on that? Okay, so here's a question for you. If you have a pentagonal prism and you're trying to find B, a pentagonal prism, and you need B. What formula are you using?
Oh my gosh, do we have the?
It's, no, it's,
No, I don't want to do that.
What is it?
It's gonna be,
It's the area of a pentagon, which is 1/2 AP, right? So maybe you want to pull up your chapter 10 formula sheet in case you forget what other formulas are. I told my last class I might just put that formula sheet on the back of the other formula sheet so you have the area formulas and the surface area lateral area formulas. It's not a bad idea. Anyway, any questions?